The future is electric. The transition from traditional combustion engines to electric vehicles, EVs, is accelerating at an unprecedented pace, driven by the urgent need to combat climate change and reduce air pollution. As we stand on the precipice of this transformation, let's delve into the multifaceted aspects of this revolution and its far-reaching implications. The urgency to shift to EVs stems primarily from the environmental crisis we face today. As the largest source of greenhouse gas emissions, the transportation sector is pivotal in achieving emissions reduction goals. Traditional vehicles powered by gasoline or diesel contribute significantly to air pollution and premature deaths due to particulate matter they emit. EVs, on the other hand, produce zero tailpipe emissions. The more we embrace EVs across personal, public, and commercial transportation, the better the outcomes for our public health. Studies have found that increased EV adoption leads to improved air quality and fewer health-related hospital visits, making it a crucial strategy for addressing the climate crisis. The EV revolution also presents significant economic opportunities. Between 2020 and 2021, the number of EV jobs grew by over a quarter in the United States. Massive investments are pouring into domestic production of EVs and their batteries, as well as the construction of the nation's charging network. This is expected to spawn tens of thousands of new jobs, ranging from auto workers to electricians. Moreover, EVs can lower utility costs, as people generally plug in their EVs overnight when the demand for electricity is low. EV drivers can actually drive down electricity rates for all customers. Another often overlooked advantage of EVs is their potential to reduce noise pollution. Compared to combustion engine vehicles, EVs are nearly silent when traveling at low speeds, creating a more pleasant and quieter urban soundscape. Transitioning to EVs is not without its challenges. The biggest hurdle is perhaps the need to install expensive charging stations and ensure that the electrical grid can cope with the increased load. High upfront costs and range anxiety, the fear of being stranded due to limited battery range, also pose significant barriers to EV adoption. However, with ongoing technological advancements, these challenges are gradually being overcome. The average cost of EVs is decreasing and their ranges are improving. Governments and private companies are heavily investing in building more charging infrastructure. Government policies and regulations play a critical role in accelerating the EV shift. The U.S. Environmental Protection Agency has recently proposed federal clean car standards that could put the United States on a path to ending tailpipe pollution. However, these regulations are likely to face economic, logistical, and legal challenges. Manufacturers may resist the rapid transition, consumers may be hesitant, and legal challenges may emerge from those who consider the regulations as government overreach. The transition to EVs will also necessitate a significant transformation of our transportation infrastructure. Currently, our cities and roads are tailored to cater to gas-powered cars. The arrival of EVs, with their unique characteristics such as extreme acceleration and silent operation, will require adjustments in our driving habits, road designs, and city planning. Driving an EV is a different experience from driving a traditional car. For instance, EVs can accelerate extremely quickly due to the direct power supply to the wheels. This can make driving an EV more enjoyable, but can also pose safety risks if drivers are unprepared for the rapid acceleration. EVs require less maintenance and fewer repairs than their traditional counterparts. Many fixes can be done via over-the-air downloads, similar to updating your phone's operating system. This shift could potentially reduce the demand for traditional auto repair shops and mechanics. One of the less discussed aspects of EVs is their weight. Due to their heavy batteries, EVs can weigh hundreds of pounds more than traditional cars. This increased weight can create safety concerns, particularly for pedestrians and passengers in other vehicles. Just like your phone's battery, the performance of an EV's battery can be affected by weather conditions. Cold temperatures can slow down the chemical reactions that power the batteries, reducing their efficiency. Furthermore, in the aftermath of extreme weather events like hurricanes, the risk of battery-related fires can increase. The future of electric vehicles looks incredibly promising. As technology continues to advance, we can expect more affordable EVs with longer ranges. The expanding charging infrastructure is making it easier than ever to charge EVs on the go. As more and more consumers embrace EVs, the auto industry is inevitably shifting its focus towards electric power. The shift to electric vehicles marks a transformative revolution in transportation. While the transition presents its own set of challenges, the environmental, economic, and societal benefits make it a critical and inevitable change. As we navigate through this revolution, we need to adapt, innovate, and collaborate to build a more sustainable and greener future. The electric vehicle revolution is not just about swapping out gas-powered cars for electric ones. It's about reimagining our entire relationship with transportation and paving the way for a cleaner, healthier planet.